So the first quiz, the calculation we're going to look at is relative atomic mass, which can come up on paper 1 or on paper 2. And before looking at the calculation, we're just going to briefly look at where the calculation comes from. So here I've drawn out two different atoms of lithium. Okay, I know they're both atoms of lithium because they both have the atomic number 3, and it's the atomic number that we use to identify an atom. Because they both got the atomic number 3, they both have 3 protons, they both have 3 electrons. What's different between these two atoms of lithium is the mass number. On the left, the mass number is 6, on the right, the mass number is 7. This change in mass number is because I've got a different number of neutrons. On the left, I've got 6 minus 3 is 3 neutrons. On the right, I've got 7 minus 3 is 4 neutrons. So the number of protons is the same, but the number of neutrons is different. Therefore, I can call these lithium isotopes, as they've got the same number of protons, but a different number of neutrons. I've highlighted protons and neutrons because protons and neutrons have mass. Protons have a mass of 1, neutrons have a mass of 1. When I've got 3 protons and 3 neutrons, my mass number is 6. When I've got 3 and 4, my mass number is 7. I don't include the electrons in the mass because electrons are very light and their mass is negligible. However, even though 2 different isotopes of lithium exist, with 2 different mass numbers, if I look at the periodic table, only one of those isotopes is represented, the lithium with a mass number of 7. So why was that lithium chosen? Well, in actual fact, what's represented on the periodic table is the result of a calculation of relative atomic mass. And in this calculation, you take into account how common each of these isotopes are. So if you had 100 lithium atoms, 92.4% of them would have 4 neutrons and a mass of 7, and only 7.6% of those lithium atoms would have 3 neutrons and a mass of 6. And I take this percentage abundance, or how common the isotopes are, into account when I'm calculating relative atomic mass. What I do is I take the percentage, so for the first I've got a percentage of 7.6%, and I multiply by the mass number. Remember, we're calculating relative atomic mass, so if you're confused about which number to take, it's always going to be the mass number calculating mass. So it's going to be 7.6 multiplied by 6 plus the 92.4, the percentage, times the mass of the other lithium isotope, and I divide everything by 100. When I do this, I end up with an answer of 6.9, and to round that up to just to a whole number, I end up with 7, which is the same answer that I see on my periodic table. So when you're doing these calculations, if your answer doesn't match the mass number on the periodic table, you know you've done it wrong. And if you ever get confused between which one is mass and which one is atomic, you're given a key. It tells you that the number at the top is the mass, and it tells you that the number at the bottom is the atomic, and this key is given to you in your exam. If we look at another example, this time with iron, iron also exists as 3 different isotopes. Because the atomic number is 26 in each case, I know it is iron. The atomic number is what identifies an element. Because it's got an atomic number of 26, it always has 26 protons and 26 electrons. Because the mass number changes, I've got a different number of neutrons each time. So same number of protons, different number of neutrons. I've got different isotopes of iron. This time I've got 3 isotopes instead of just 2, but the calculation is going to be the same. I need to look at how common each of these isotopes are. This isotope, only 5.9% of all iron isotopes have a mass of 54. This one here, by far the most common, and then this one here, the least common. Doing the calculation, it's the percentage multiplied by the mass number plus the percentage multiplied by the mass number plus the percentage multiplied by the mass number, divide everything by 100, I get 55.9, I round that up to 56. I check my answer on the periodic table, I see that the answer is indeed 56, so I know I've done it correctly. The common mistake with these that I always see is sometimes students add the percentage and the mass number, and then multiply here. Okay, if you do it the wrong way around, you get a totally different answer. By checking your answer with the periodic table, you'll know if you've made a mistake. Your equation question on quiz 1 is writing a word equation when given the reactants and products. This is really simple. You're given all of the information, you just need to turn it into an equation. If you're asked for a word equation, that's what you should write. In the exam that I just marked, every time you were asked for a word equation, a lot of you wrote symbol equations instead. That is much harder. Unless you get the symbol equation absolutely spot on, you're not going to get any of the marks. So if you're asked for a word equation, just write a word equation. In the 2 examples I've given you, you're given everything that you need. You just need to be able to read it and decide what goes on the left of the arrow, what goes on the right. It says the salt copper sulfate can be made. Okay, if that's what you're making, that's your product, that's going to go on the right hand side of your arrow by reacting the base copper oxide with sulfuric acid. So copper oxide and sulfuric acid, they are what you are reacting. They're going to go on the left hand side of your arrow. It then says water is also produced. Again, water is being made. It's going to go on the right hand side. So that's what it's going to look like. Copper oxide and sulfuric acid reacting to give you copper sulfate and water. You must use an arrow, not an equal sign. The next one, wanted to measure the rate of the reaction between magnesium and hydrochloric acid. So magnesium and hydrochloric acid, they are what are reacting. That's what's going to go on the left-hand side, the magnesium and the hydrochloric acid. Then I draw my arrow, not an equal sign, and I read the rest of the question, and I see that hydrogen gas is produced, so that's a product, it's going to go on the right. Magnesium chloride is also a product, it's produced, it's going to go on the right. So products on the right-hand side of the arrow, reactants on the left. Use an arrow, not an equal sign. As long as you read your question properly, you're given all the information you need to write a word equation. It should be an easy mark.